Hi, folks. All right, so welcome to the 6.3 section that's just kind of about the theory or the background. Like, where did these graphs come from? Why do they have the domains and ranges that they have? Okay, so on Wednesday, we're going to learn about graphs of sine and cosine. All right, and so we're sort of previewing a little bit here, but what we're going to learn on Wednesday is that when we have a graph of sine, okay, our graph of sine is going to look like a wave. And specifically, it's going to look something kind of like this. So highest point will be 1, the lowest point will be -1. And then our graph will kind of go like this, up and down and down and up. And then same thing over here. And so we'll have sort of this wave-like pattern for the graph of sine, okay? And some of you might be familiar with that already, but one thing we do know about the graph of sine is that it does the waves keep going. So we can put arrows on the ends of that graph, okay? And the graph will keep going up and down over and over again. Now you'll notice that I labeled the y-axis, but I didn't label the x-axis yet. So it turns out that the first mark on here is going to be pi over 2, or the first quadrantal angle. The next mark is at pi, and then 3 pi over 2, and then 2 pi. And if we count in the other direction, we'll get negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, okay? So that looks a little bit different because we're counting by pi. But when we think back to what we know about an inverse, we know that we can take a graph and we can reflect it over the line y equals x. That was something we learned in Math 116. That in general, when we have an inverse, it is a reflection over the line y equals x, okay? Now, if I took this whole blue graph and I reflected it, what I would end up with is a function that looked something kind of like this. Okay. Actually, I think it will go more like this. Okay. And so one thing about this graph that is a big violation of the definition of a function is, whoops, it fails the vertical line test, right? It crosses that vertical line 1, 2, 3, 4 times, and that's just on the part that I reflected. So if I reflected the whole graph, it would fail the vertical line test big time, and that would mean it's not a function. And so one of the things that we really need to do then is when we reflect it, we only want to choose a chunk of the graph to reflect. And that's why the graph of inverse sine is so small, because we only take a part of the sine graph and reflect it, okay? And so if we think about what part to take, it turns out that somewhere along the lines, mathematicians said, let's take this middle piece right here, that yellow piece. So we're going to take the chunk that is, let's see, what's this coordinate? Negative pi over 2 comma negative 1. And then this point is pi over 2 comma 1. We're going to take that chunk and only reflect that chunk. Now, the reason why they picked it is because it has some positive values, it has some negative values, and it includes all of the values in between -1 and 1, okay? And so if we take just this part and reflect it, well, what are we going to get? Okay, so one of the other ways we thought about inverse functions was that you take the x and y and you switch them. So I'm going to take this coordinate and switch the x and y. So that'll be -1 comma negative pi over 2. And so if I label my inverse graph, I'm going to go from -1, 1, pi over 2 to -pi/2. And so my first point will be -1, comma, -pi/2. My last point will be 1, comma, pi/2, because I took this point and switched the x and y. And then I can even grab this middle point here too, 0, 0. And so that'll mean that this inverse sine graph goes through the origin, okay? And so when we sketch it, it should look something kind of like. And so that's why the inverse graph of sine is so small. It's just a piece of it because we didn't want to get repetition too much, okay? Now, what that means then is we can use this graph to describe our domain and range. So domain of that graph, let's put it down here. The domain of this graph is all the x values, which is from -1 all the way to 1. And the range is from -pi/2 to pi/2. Okay? And the way that we might find that really helpful is to kind of, as folks already did in class, think about it in relation to the unit circle. Okay? That for arc sine or inverse sine, we're only grabbing values from the right half of the unit circle, from -pi/2 to pi/2. Okay? So we want to make sure that we're only grabbing values from there. That's really where we need to think about renaming some of the angles in order to fit between those two numbers, okay? So that's a little bit on the inverse sine function. Now we can take the cosine graph and flip a piece of it too, and we'll end up with the inverse cosine. And we can take the tangent graph, flip that, and we'll get the tangent graph, the inverse tangent graph, okay? All right, so inverse cosine. Well, let's start with what the graph of cosine looks like, all right? So we're gonna learn this on Wednesday, but just to give you a preview, all right, we're gonna set this up the same way. We're gonna have a high y value of 1, a low y value of -1. We're gonna count by pi/2, just like we did before, and in the negative direction. And the graph of cosine looks like this. 1, 0, -1, 0, 1. And because cosine's even, it's going to be symmetric about that y-axis. And so we end up with a wave like we did with the other. Okay. And so when mathematicians were looking at this graph and they were like, which part should we pick this time? One problem they ran into is if they picked the same region as inverse sine, they didn't get any of the negative values. Like there's nothing below the graph. I don't get any of the values that are between 0 and -1. So they're like, that's not going to work. We need to pick a different section. They wanted a section that had all the values from -1 to 1. And so because this is what the cosine graph looks like, they grabbed these values, which made the piece that we're reflecting just to be from 0 to pi, okay? So if we sort of sketch that out, okay, we get 0 all the way up to pi, and then from -1 to 1, all right? And if we take the coordinates and flip them like we did the last time, this is, let's see, 0, 1. So that's going to be 1, 0. So that becomes this point, 1, 0. And this point down here is pi, -1. So then it switches to become -1, pi, or up here. Okay. And we know that this point also is pi over 2, 0. And so when we flip it, it should go right there at 0, pi over 2. And that's how we end up with the inverse cosine graph. Pretty cool, right? All they did was take one part of the cosine graph and just reflect it. And so if we think about our domain and range here, we can look at the graph. So the domain is it starts from 0, goes up to pi. The range, I'm sorry, that was our range, 0 to pi. The domain goes from -1 to 1. Okay. And so if we want to think about what this is on our unit circle, it means for arc cosine, we want to choose from the top half of the circle, anywhere between 0 and pi, because that's the yellow part of the segment that I chose from the sine graph, okay? So the green part on the unit circle is the same as that yellow band on the cosine graph. All right, so now let's take a look at this one last function. So the tangent graph, we're probably going to learn on Monday of next week, okay? But the tangent graph looks a little bit different than the sine and cosine graph. We still set up the x-axis the same way. We have our pi, 2 pi, our halves in between, -pi, -2 pi, our halves in between, okay? But the graph of tangent actually has a bunch of vertical asymptotes. So at -pi over 2, pi over 2, 3 pi over 2, -3 pi over 2, those are all vertical asymptotes for the graph of tangent. And in between those vertical asymptotes, we have these branches that kind of look like the cubic function, if you remember those from Math116. But instead of just one of them, there's like a lot of them. And so here we would only have the first part, here we would have the second part, okay? And we'll talk about where all these things come from. But when mathematicians were like, well, which part of the graph should we flip? They just decided to pick one of the branches. And they picked, like for sine, they picked the one that goes from -pi over 2. Let's label that -pi over 2 to pi over 2. And when we flip that one, what do we end up with? Well, we end up with a graph that looks like this. Now, I probably should have done that in purple, but that's okay. This is the part that gets reflected is that whole middle branch. And then what else gets reflected is we have those vertical asymptotes now becoming horizontal asymptotes. Okay. And so when we think about our inverse tangent, our domain, our range, and then we'll draw a unit circle, the domain, we can see it goes side to side forever and ever. That's why it's -infinity to infinity. And the range, well, that's what y values come out. It goes not including -pi over 2, all the way to almost pi over 2, so we close it with a parenthesis. And if we want to visualize this on our unit circle, we can draw a quick unit circle. And remember that we're only going to choose, whoops, not that. We're only going to choose from the right half of the unit circle from negative pi over 2 to pi over 2. Okay? And so that's just a little bit of the sort of reasoning behind why we have sort of these small graphs, or why the graphs look the way they do, or why we can only choose from certain answers to get the right answer. Okay, it all has to go back to that idea of the range. We have to meet the range of the given function. Okay, so I hope that makes a little bit more sense, and thanks for taking the time to watch this video, and I'll see you folks in class on Wednesday.